Good morning, chemistry students. Here are the corrections or going over ChemQuest 37, balancing equations. Question number 1 asks you to write the equation for the reaction of sodium and chlorine to form sodium chloride. So again, we're going to start with our word equation, which would be sodium plus chlorine, arrow sodium chloride. Okay, so now we're ready to write our skeleton equation. So our symbol for sodium is Na. Chlorine, it reminds you here that it's diatomic. We know it's diatomic because it's part of Dr. Brinkelhoff. And sodium chloride is an ionic compound, so our symbols and charges, crisscross, lowest whole number ratio. Now we're ready to balance. 1 sodium, 2 chlorines, 1 chlorine, so we need a coefficient of 2 in front of sodium chloride, which means we need a coefficient of 2 in front of sodium, and it is now properly balanced. Number 2 says write the equation for the reaction of calcium nitride and sodium chloride to produce calcium chloride and sodium nitride. Again, we're going to first write our word equation. So that's going to be calcium nitride plus sodium chloride to produce is our arrow, calcium chloride plus sodium nitride. So now that we have our word equation, we're ready to write our skeleton equation. Again, these are all ionic compounds, so every single time we'll do symbols, charges, crisscross, lowest whole number ratio. So Ca plus 2, N negative 3, crisscrossing, sodium Na, chloride Cl, Ca plus 2, Cl negative 1, plus Na plus N negative 3. So now that we have our skeleton equation, we're ready to balance. 3 calcium, 1 calcium, we need a coefficient of 3 in front of calcium chloride. 2 nitrogens, 1 nitrogen, we need a coefficient of 2 in front of sodium nitride. 1 sodium, 2 times 3 makes 6 sodium, so we need a coefficient of 6 in front of sodium chloride. 6 chlorides, 3 times 2 makes 6 chlorides. This is now properly balanced. So we have information next, subscripts and coefficients. A subscript is a small number that tells you how many atoms are in a compound. For example, in CaCl2, the 2 is the subscript and it tells us that there are 2 chloride ions bonded to 1 calcium. A coefficient tells us how many atoms or compounds there are, but in a different way. For example, in the expression 3H2O, the 3 is the coefficient. The 3 tells us that there are 3 molecules of water present. In the expression 3H2O, there are a total of 6 hydrogen atoms and 3 oxygen atoms. Question number 3, verify that in 4Ca3PO42 there are 32 oxygen atoms present. So we're just looking at oxygen. So first, this 2 times that 4 gives us 8. And then multiplied by this 4 gives us 32 oxygen atoms. Number 4, how many oxygen atoms are in each of the following? So 3 oxygen, there's no coefficient here, so this just has 3. There's no subscript here, so that's a 1, but there's a coefficient in front of a 3, so that is 3 again. Here we have this 4, and then times this 4, which gives us a total of 16 oxygen atoms. And in our last one, we have this 2 times this 3, which gives us 6, times this 5, which gives us 30 oxygen atoms. So we have some information how to balance equations. Consider the reaction of sodium and chlorine to produce sodium chloride from question 1. Remember that when chlorine is by itself, it is always written as Cl2. On the reactant side of the reaction, left side, there are a total of 2 atoms of chlorine, but on the product side, there is only 1 atom of chlorine. Atoms cannot simply disappear. In order for the equation to make sense, we need to balance the equation. Atoms cannot simply, this can be done first by adding a 2 to the product side in front of sodium chloride. Now the equation reads that 1 atom of sodium reacts with 1 molecule of chlorine to produce 2 units of sodium chloride. However, now the sodium atoms are not balanced because there is 1 atom of the reactant side, but 2 atoms of sodium on the product side. This can be fixed by adding another 2. So you end up with this balanced equation that we already did. Let us consider another example equation, the equation you wrote in question 2 above. Notice that none of the atoms are balanced. There are 3 calcium atoms on one side and only 1 on the other. There are 2 nitrogen atoms on one side and 1 on the other. How can we fix this? Begin by balancing 1 atom at a time. Number 1, first let's balance the calcium atoms by placing a 3 in front of calcium chloride. Number 2, next let's balance the nitrogen atoms by placing a 2 in front of sodium nitride. Number 3, now we will balance the sodium atoms by adding a 6 in front of sodium chloride. Number 4, finally examine the chlorine atoms and notice that they are already balanced. Number 5, double check each atom to make sure there are equal numbers of each on both sides of the equation. When balancing equations, you never change subscripts, only change the coefficients. So that brings us to question number 5. Which of the following equations are properly and completely balanced? Circle as many as apply. So you see here we will correctly balance these next. But looking at what they have, I have 2 sodiums here and 1 sodium here, so that I'm not going to circle letter A. That's not correctly balanced. I have 3 carbon here and I have 3 carbon here, so that looks okay. I have 8 hydrogen here. I only have 2 hydrogen here, so again, I'm going to X that out. That's not properly balanced. Letter C, 1 magnesium, 1 magnesium, 2 chlorines, 2 chlorines, 2 fluorines, 2 fluorines. I am going to circle letter C. Letter C is correctly balanced. Again, that's a skeleton equation. That's a balanced equation. Letter D, 1 iron, and we have 2 irons, so again, I know right away that letter D is not correctly balanced. So we're going to go ahead now and correctly balance A, B, and D. Here's equation A for us. So we have 1 sodium and we have 1 sodium, so that's okay. We have 1 chlorine and we have 2 chlorine, so we need a coefficient of 2 in front of sodium chloride, which means we need a coefficient of 2 in front of sodium. We have 1 copper and 1 copper, so this is the way to properly balance this chemical equation. Letter B, we have 3 carbons and we have 1 carbon, so we need a coefficient of 3 in front of carbon dioxide. We have 8 hydrogens and we have 2 hydrogens, so we need a coefficient of 4 in front of water. Now I have 3 times 2, which is 6 oxygens here, plus 4 more gives me 10 oxygens total. So to get 10 oxygens on the reactant side, I need a coefficient of 5 to do so. So now equation B is properly balanced. Equation C, remember, we already said that this happened to be a skeleton equation that was a balanced chemical equation, so nothing necessary for that one. So equation letter D, we have 1 iron and 1 iron. We have 2 chlorines, we have 2 chlorines. We have 2 oxygens and we have 1 oxygen, so we need a coefficient of 2 in front of the iron oxide, which also means we need a coefficient of 2 in front of iron chloride, which means we need a coefficient of 2 in front of chlorine. I think I'm balanced. I'm going to check. 2 irons, 2 irons, 4 chlorines, 4 chlorines, 2 oxygens, 2 oxygens. This is properly balanced now. Number 6, balance each of the following equations by inserting the correct coefficient in each blank. Remember to balance one atom at a time. If the number 1 belongs in the blank, you may either leave it blank or insert the number 1. I'm just going to leave it blank if it should be a number 1. So 1 calcium, that looks okay. 2 chlorines, and I have 1 chlorine, so I need a coefficient of 2 in front of lithium chloride. 2 lithiums, that's balanced. 1 oxygen, so that is balanced. So now we have this correctly balanced. Letter B. 2 aluminums, 1 aluminum, we need a coefficient of 2 in front of aluminum. 3 sulfurs, 1 sulfur, we need a coefficient of 3 in front of copper sulfide. 1 copper, 3 coppers, we need a coefficient of 3 in front of copper. And now this is properly balanced. Letter C. 3 sodiums, 1 sodium, we need a coefficient of 3 in front of sodium bromide. 1 phosphorus, 2 phosphorus, we need a coefficient of 2 in front of sodium phosphide, which means I need to change this 3 to a 6 now, because now I have 2 times 3, 6 sodiums. Magnesium, I have 1. Magnesium, I have 3. So I need a coefficient of 3 in front of magnesium bromide. And I have 3 times 2, which is 6 bromines. And I have 6 bromines. I think I'm balanced. I'll double check. 2 times 3 is 6 sodiums. 6 sodiums. 2 phosphorus. 2 phosphorus. 3 magnesium, 3 magnesium. 2 times 3, 6 bromides, 6 bromides. This is properly balanced. Question number 7 just says, here are the answers to question 6. Double check your answers to question 6. Then we have some information. Balancing equations containing polyatomic ions. When an equation contains polyatomic ions, it may look a little more difficult to balance. But balancing an equation containing polyatomic ions is really not much different from the ones you just did. In the equations above, you kept in mind that you must balance only one atom at a time. With polyatomic ions, keep in mind that you balance one polyatomic ion at a time. For example, consider the following unbalanced equation. Sodium sulfate reacts with calcium phosphate to produce sodium phosphate and calcium sulfate. The first thing you should do is take note of which atoms or ions are not balanced. Keep the polyatomic ions together. In other words, do not balance the phosphorus and oxygen atoms separately. Instead, balance the phosphate ions on each side of the reaction. Follow these steps. Step number 1, balance the sodium so that there are 6 sodium atoms on each side of the reaction. Step 2, now there are 3 sulfate ions on the left and 1 on the right. Add a 3 to the right. Number 3, take inventory of all the atoms and ions to make sure they are balanced. The equation is now balanced. So that brings us to question number 8, which is, which of the following equations are properly balanced? Again, you see, we're going to properly balance them next. So right now we're just going to see if they are. So 1 barium, 1 barium, 2 nitrates, 2 nitrates, 2 irons, 2 irons, 1 sulfate, 1 sulfate. We should circle letter A because letter A is correctly balanced. Letter B, 3 strontiums, 3 strontiums, 6 chlorides, 3 chlorides. So we're going to put an X through B because we already know it's not properly balanced. All right, letter C, 3 calciums, 3 calciums, 2 phosphates, 2 phosphates, 6 sodiums, 6 sodiums, 3 carbonates, 3 carbonates. We're going to circle letter C because letter C is also properly balanced. Letter D, 1 iron, 1 iron, 2 nitrates, 2 nitrates, 1 magnesium, 1 magnesium. We're also going to circle letter D because letter D is also properly balanced. So the only one we need to correctly balance is letter B, which is right here. So this one up here was properly balanced. We don't need to do anything because it was fine the way it was with the coefficient of 2 in here. For letter B, we had 1 strontium, 1 strontium, 2 chlorides, and 3 chlorides, so we need a coefficient of 2 in front of strontium chloride, a coefficient of 3 to make 6, and a coefficient of 2 in front of aluminum chloride. So now I have 3 strontiums, so that also means I need a coefficient of 3 in front of strontium nitrate. I have 6 chlorides, and I have 2 times 3, 6 chlorides. I have 1 aluminum, and I have 2 aluminum, so I need a coefficient of 2 in front of aluminum nitrate. I have 2 times 3, 6 nitrates. I have 3 times 2, 6 nitrates. So I think I'm balanced. I'm going to double check. 3 strontiums, 3 strontiums, 6 chlorides, 3 times 2, 6 chlorides, 2 aluminums, 2 aluminums, 2 times 3 is 6 nitrates, 3 times 2 is 6 nitrates. This is now correctly balanced. So number 9 asks us, because letter C and D, remember, were properly balanced. Okay. So number 9 asks us to balance each of the following equations by inserting the correct coefficient in each blank. Remember to balance one atom or ion at a time. If the number 1 belongs in the blank, you may either leave it blank or insert the number 1. Again, I'm just going to leave it blank. So, again, we have 1 calcium and we have 1 calcium, so that's okay. We have 2 nitrates and we have 1 nitrate, so we need a coefficient of 2 in front of sodium nitrate. We have 1 sodium and we have 2 sodium, so we need a coefficient of 2 in front of sodium. And now it is properly balanced. Letter B, we have 2 aluminums, 2 aluminums, and we have 1 aluminum, so we need a coefficient of 2 in front of aluminum chloride. We have 3 carbonates, we have 1 carbonate, so we need a coefficient of 3 in front of magnesium carbonate. We have 1 magnesium, we have 3 magnesiums, we need a coefficient of 3 in front of magnesium chloride. 3 times 2 is 6 chlorines, 2 times 3 is 6 chlorines, so this is now properly balanced. Letter C, we have 3 bariums, we have 1 barium, so we need a coefficient of 3 in front of barium carbonate. We have 2 phosphates, we have 1 phosphate, we need a coefficient of 2 in front of sodium phosphate. We have 2 sodiums, we have 2 times 3, which is 6 sodiums, so we need a coefficient of 3 in front of sodium carbonate. We have 3 carbonates, we have 3 carbonates. This is now properly balanced. Question number 10 says just make sure you got the following answers for question 9, which we did. Question number 11, complete and balance the following equations. So now the difference is, right, that they didn't tell us the type of reaction. So just as kind of a means of review, I'm going to go back through this real quick, and we're going to identify these reactions as one of our 5 types every time. And I'm going to do that in, well, let's pick something kind of fun. All right. So in this reaction, right, I have 2 reactants. They're both elements producing one compound. This is a combination or synthesis reaction. I go to number 2. I have 2 reactants. They're both compounds. This is a double replacement reaction. I come to number 3. This one isn't a reaction, so nothing to identify. Same thing with number 4. I come to number 5. We'll look at these on our next slides. Letter A here, I have a compound reacting with an element. So this is single replacement. In the second one, I have a hydrocarbon reacting with oxygen. This is combustion. Letter C, I have a compound reacting with an element. This is single replacement. In letter D, I have a compound reacting with an element. So this is single replacement again. This one, I have a compound reacting with a compound, so this is double replacement. And again, this is important because to be able to predict the products like we need to do in number 11, we need to be able to know what kind of reaction it is. Letter B, we have an element reacting with a compound, so this is a single replacement reaction. In letter C, we have 2 compounds reacting, so this is a double replacement reaction. And that was the answers. In number 8 here, we have in this top one a compound and a compound reacting, so that's double replacement. In letter B, I have a compound and a compound, so that's another double replacement. In letter C, I have a compound and a compound, another double replacement. And in letter D, I have a compound and an element, so that's a single replacement reaction. Number 9, again, we have a compound and an element, so this is a single replacement reaction. Letter B, this is a compound and a compound, so that's a double replacement. We also have a compound and a compound here, so this is another double replacement reaction. All right, so that brings us to number 11, completing and balancing the following equations. So to identify this reaction as to type, okay, again, I have, okay, an element reacting with a compound. So this is a single replacement reaction. So we should check and see that magnesium is higher on our activity series. And it is. So remember, the ones that are alike are going to swap partners here. So magnesium is a metal. Hydrogen is acting like a metal here in this hydrochloric acid. So hydrogen is going to be by itself, but I have to write it as H2 because it's part of Dr. Brinkelhoff. And magnesium chloride is an ionic compound, so Mg plus 2, Cl negative 1, so MgCl2. Now I'm ready to balance this. 1 hydrogen, 2 hydrogens, I need a coefficient of 2 in front of hydrogen chloride. 2 chlorines, 2 chlorines. 1 magnesium, 1 magnesium. This is now properly balanced. All right, part B, identifying this reaction as to type. Again, I have a compound reacting with a compound, so this is double replacement. Again, in double replacement reaction, positive ions swap partners. So sodium and beryllium are going to swap. So these are going to be ionic compounds. So again, I'm going to have sodium, and its partner is going to be hydroxide. So nothing to do to that one. Beryllium, and its partner is sulfide. So again, nothing to do to that one. So now I'm ready to balance this. 2 sodiums, 1 sodium, coefficient of 2 in front of sodium hydroxide. 1 sulfur, 1 sulfur, 1 beryllium, 1 beryllium. 2 hydroxides, 2 hydroxides. This is now properly balanced. Letter C. Again, I have 2 compounds reacting, so this is double replacement. Again, sodium and barium are both metals. They're going to swap partners. So I'm going to have barium is going to have a partner of nitrate. And sodium is going to have a partner of fluoride. So now those are written correctly. Now it's time to balance them. 1 barium, 1 barium, 2 fluoride, 1 fluoride. I need a coefficient of 2 in front of sodium fluoride. 1 sodium, 2 sodiums. I need a coefficient of 2 in front of sodium nitrate. 2 nitrates, 2 nitrates. This is now properly balanced. Letter D. Again, I have 2 reactants that are both compounds, so this is a double replacement reaction. Calcium's a metal and potassium's a metal, so they are going to swap partners. So calcium's partner is going to be sulfate. And my other product is potassium with phosphate. Again, these are all ionic compounds, so I have to do symbols, charges, crisscross, lowest whole number ratio. So now that I have my formulas written correctly, I'm ready to balance. I have 3 calcium, I have 1 calcium, I need a coefficient of 3 in front of calcium sulfate. I have 2 phosphates, I have 1 phosphate, I need a coefficient of 2 in front of potassium phosphate. 2 potassiums, I have 6 potassiums, I need a coefficient of 3 in front of potassium sulfate. I have 3 sulfates, I have 3 sulfates. This is now properly balanced. Letter D, this is a single replacement reaction. So again, I should check and see that magnesium is higher than zinc on my activity series of metal. And because magnesium is a metal, it's going to take zinc's place. So our products are zinc by itself and magnesium with nitrate, which is an ionic compound. So now I have this written correctly. Now I'm ready to balance. 1 zinc, 1 zinc, 2 nitrates, 2 nitrates, 1 magnesium, 1 magnesium. This is a skeleton equation that is also a balanced equation. Letter F, 2 compounds reacting, so I have double replacement again. Calcium's a metal, aluminum's a metal. They're going to swap partners. So calcium's partner is now going to be carbonate. And my other product is going to be aluminum with nitrate. So I need parentheses and a 3 when I crisscross. So now I'm ready to balance. 1 calcium, 1 calcium. 2 nitrates. I have 3 nitrates, so I need to make them 6. I'm going to put a coefficient of 3 in front of calcium nitrate. coefficient of 2 in front of aluminum nitrate, which means now I need a coefficient of 3 in front of calcium carbonate. I have 2 aluminums, I have 2 aluminums, I have 3 carbonates, I have 3 carbonates. This is now properly balanced. I hope that helps. If you had some questions over ChemQuest 37, balancing equations, have a great day.